hi everybody, this is Mr. Klein, and I'm back to work with you on systems of equations, talking about the third method. So far we've learned graphing, we've learned how to solve these by using the substitution method, today the elimination method. And we're pretty much doing exactly what that says, eliminating something. We're terminating, we're getting rid of something. So the first thing that we need to do here is let's see if we can just eliminate something from this set of equations. So we have x plus y equals 15, x minus y equals 5. Is there anything, when we look at these two equations, that kind of cancel each other out? Well, what the idea is we can actually add these two equations together. Because when you look, you have a y and a negative y. Well, if we add all of these together, every term, this is going to cancel out. It's going to eliminate. So x plus x is 2x. The y plus a negative y cancels out. This is now gone. And remember, we're adding every term. 15 plus 5 is 20. All right, from there, we've just got a one-step equation now. Divide both sides by 2. So x equals 10. But we're not quite finished yet. Remember, we need a point. Our solution needs to be a point. So we can take either equation and we can plug in our value of x and then evaluate. So let's use that top equation. We have x plus y equals 15. And let's just plug in 10 for x. 10 plus y equals 15. We want to isolate y. So let's subtract 10 from both sides. That's going to cancel out. Now we've got y equals 5. So as you can see, we've got our value of x equals 10, y equals 5. So final thing, we just write our solution. 10, 5. There it is. That is our solution. We just use the elimination method to do this. As you can see, in the graphing method, it worked out nicely to use graphing because they were already in slope-intercept form. We didn't have to manipulate the equations. If they were in slope-intercept form, graphing is a pretty easy way to do it, although it can be time-consuming. Substitution, when one of the variables is isolated, it makes sense to use substitution. When they're both in this form, elimination can be a pretty useful way to do it, especially when you already see kind of a natural place where things can be canceled out. Let's do another example, and you guys will be ready to practice. Of course, I almost forgot. Doing a check always makes sense. Of course, we could at least plug it into 1 just for good measure and just do a quick check here. Let me do a check right here. So here's our check. Let's just use that top equation, x plus y equals 15. You really don't even need to write anything down. You could use mental math here. Our value of x was 10, value of y was 5. Sure, 10 plus 5 is 15. 15 equals 15. And for good measure, you certainly could put it into both equations. You'll find out that it will equal 10 minus 5 equals 5 if you look at the equation over here. So it's always good to check, and no matter what method you use. Let's move on to the next problem. All right, everybody, let's take a look at a second system here that we want to solve. We're going to use the elimination method. Now, in this case, as we look at these two equations, there is no clear place where it's just ready to add the two equations together and eliminate something. we need to make there's one extra step here so that we have a positive and a negative that will cancel out. So what we can do is if we multiply this second equation, we certainly could do it to the first or the second, but let's do it the second one. It's going to change the sign of each of these terms. And ultimately, we want to get this x to be a negative x, so this term cancels out, so we're only left with y's. So what we're going to do is we're going to multiply everything in this equation by negative 1. So this will become negative x. This will become negative 3y. This will become negative 4. Let's go over here. And now let's combine these. Let's add these equations. So we have x minus 2y equals 9. And then we have negative x minus 3y equals negative 4. Okay, we're ready to combine them. So we're going to add these together. Well, x minus x cancels out. Negative 2y plus negative 3y is a negative 5y. Be careful with negative integers, guys, adding and subtracting them. So you have a negative 5y, and we have a 9 plus a negative 4. That's going to get us 5. Pardon me. Now, one-step equation. Divide both sides by negative 5. Got to get y by itself, remember? Gosh, my voice cracked again. What's going on? These cancel out. Got y equals negative 1. 5 divided by negative 5 is negative 1. So there we go. We've got our value of y. Y equals negative 1. We still need to go back, plug y into one of these equations to get our x. So let's plug that in to the top equation here. Use a different color. So we're going to plug y in to where we see y in this top equation. So we'll just kind of draw an arrow over here. Got x minus 2y equals 9. Now we're going to plug that negative 1 in. So we have x minus 2 times negative 1 equals 9. Well, negative 2 times negative 1 is positive 2. So now we have an x plus 2 equals 9. Subtract 2 from both sides. X equals 7. Okay. So our solution is 7, negative 1. There's our solution. Now, we could certainly check this, and I think it's a good, solid thing to do when dealing with really all of algebra. You can check most of your work, so let's just check it. Let's just plug one in. Why don't we use the top equation again? That would be fine. So our value of x was 7. Okay. And we are plugging in negative 2 times negative 1. And that should equal 9. Well, we know that negative 2 times negative 1 plus is a positive 2. So 7 plus 2, yeah, 7 plus 2 is 9. 9 equals 9. Of course, we could plug it into this equation over here as well. It would work just fine. We could plug in our 7 here and our negative 1, evaluate, and we should also get 4. All right, so that is solving systems of equations using the elimination method. The next thing you're going to do is you're going to be doing an activity with your partners when you get to when you get to class. Well, actually, it might be a partner, it might be individual. We'll see when you get to class, but you're going to be doing a lot of practice with this. Hope this video helps, and feel free to come see Mrs. Lake or myself if you have any further questions. Thanks.